So related rates. The reason it's called related rates, well, rates is a derivative, right? Rates are derivative. So that's why it fits into derivatives. Related, what is the related? Well, we're going to figure out rates that relate to the problem that we're working with, okay? So related rates means we're going to find derivatives of, or we're going to find rates and figure out a relationship, okay? So we'll get to that when we get to that. But first things first, before we even start with anything, change occurs over time, okay? That's a rate. A rate is distance over time. How far? Over how long, okay? So when we talk about how a quantity changes, we're talking about the derivative of a quantity. Quantity is how much, right? If you can answer the question in how much, that's a quantity, right? Could be miles, could be pounds, could be dollars, could be anything. How much, right? Over time, that's a rate, right? So we're going to see a lot of this. D something over dt. We're going to see a lot of t's today because we're talking about time, okay? So first thing we need to do is practice that, okay? So we need to write this rate in symbols, okay? So Marty is growing at a rate of, Shane, I got your focus up here. Shane, do I have your focus up here? Okay, phone, please turn it over. Okay, Marty is growing at a rate of 3 inches per year. That's a rate. He's growing at a rate of 3 inches per year, right? Inches is the quantity. Year is the time. How do we write that as this here? Okay. So I'll give you a hint. There's going to be an equals in the middle. So first thing we got to do is d quantity over d time. D quantity over d time. Okay. What's the quantity here?
3 inches.
Inches, right? Inches is the quantity, right? Specifics are going to go on the other side. So we're going to say d height, right? We could say height or inches. So I'll use h for height over time with respect to time, dt. Now what is the specific rate here?
3.
3. So year is one of them. What is 3?
Inches.
Three is not a quantity. 3 is a rate. So if it's a rate, it's not going to be inches. It's going to be inches per year. There you go. If it's a rate, it needs its distance over time or quantity over time. Okay? My stock portfolio is losing 5 cents per day. So how do we write that? So D, we're not going to use H because H is height. This is not height.
For quantity.
But what is the quantity here? That's what I'm saying. Like, be
It's
more
5
specific.
5 cents per day.
No, but what is the quantity? That's the specific. What is the quantity?
5.
No.
Money.
Money, right? Money. Portfolio, whatever you want to call it. You can say D money. You can say D money sign over DT. You can say DP over DT because for portfolio, portfolio is money. What you have in your portfolio is how much money you have invested. Okay? Okay, so now, what is the rate? That is the labeling. What is the rate?
-5 cents.
There we go. Negative, right? This one's going to be negative because it's losing. So -5 cents. Oops, not cents. I should write. Oh, yeah, let me do that. It's missing two things. What is it missing?
Is it over the day?
Over day, yep.
Why is it 0.05 cents? Isn't
That's what I was getting at. That's wrong. Why is it wrong?
because that's would be the amount in terms of dollars.
So if you're going to write it like that, you got to write dollars per day.
But if we're going to write it as cents, we would just put 5 cents.
No, that would be wrong.
Do you have to write it like that?
No, you can write it as cents.
So how would you write it as cents?
That's a good question. How would you write it as cents? So let's write it as cents. So dp over dt equals, how would you write that as cents? -5.
Cents.
That's wrong. Why is that wrong? Per day. There you go. That's right. Because labeling matters. And like I said, these are free response questions. They tend to be free response questions, and they will take off points for labeling. So make sure you got them labeled. If it's a rate, it's quantity over time. Okay, the radius of a circle gets larger by 4 feet per hour. So D what?
D.
So what letter would we use? What is
H.
H is height.
R for radius.
There you go. I would use R, right? Radius is dr over dt. You can write the word radius if you want, and you can write the word time if you want, but just use symbols. Okay, gets larger by 4 feet each hour. So how would I write the other part?
4 feet per hour.
4 feet per hour. Okay. We're gonna be doing a lot of this today. So the easier this is, the easier it'll be. The outside temperature is dropping by 5 degrees Fahrenheit per minute.
DT for temperature.
We could use DT for temperature. You could use DF for Fahrenheit. Either of those is okay. If you're going to use DT for temperature, make sure it's capital T, because you don't want a lowercase t over a lower. You don't want DT over DT, and one of them's lowercase and one of them's uppercase, because then that wouldn't mean the same thing. Okay, and then what would that equal?
-5 degrees Fahrenheit.
-5 degrees Fahrenheit. Per minute, yeah, per minute. Because it's a rate. It's not 5 degrees, it's -5 degrees per minute. Okay? Okay. That's the first part. So we haven't even got to the part where, we haven't even got to today's lesson yet. This is kind of background, because you're going to be doing a lot of this. They're going to ask you to label things. The second one is how to take a derivative with respect to time. With respect to time. Okay, we've actually done this before. It's been a while, but we've done it before. So we're going to find derivative of that guy. So how would I find derivative of a squared plus b squared equals c squared? It's Pythagorean theorem.
You just take the top number.
Okay, so what would be the derivative?
2a plus 2b equals 2c.
How do I say this? It's wrong, but not because of the reason you're thinking.
Because there's no respect to time.
So how do we do that?
Add a tag, like we did with the
There you go. Good. You add a tag. Each of those guys needs a tag. Why does each of them need a tag? Because neither of them is time. Is A time? No. Is B time? No. Is C time? No. Neither of them is time. So they each need a tag with them. Okay, so let me give me some space here and let me put some tags. Okay, so the first tag, we found the derivative of a squared is 2a. That's right. Not wrong, it's right. What kind of tag is it going to get?
Per second, per minute.
No. What were the tags that we did before Thanksgiving? We did tags before Thanksgiving.
dy over dx.
When we had y squared equals x plus 2, right? When did I have to do a tag? For y. Why did I have to do a tag for y? Because it was with respect, it's not with x, right? So what would this tag be? What did I find the derivative of? A, right? So it's going to be dA over what? dt, because it's with respect to time. Good. Okay. Now B. I just found the derivative of B with respect to time. C. I found the derivative of C with respect to time. That's the derivative. Okay, that is the derivative of that with respect to time. Okay? Okay. So now let's look at this guy. Same thing. This one's a little tricky. It's actually not that tricky, but it could be a little tricky. So let's start with the left side of the equal sign. A. What's the derivative of A? 1. I agree, 1. Does it need a tag? Yes. So what would the tag be for this guy? dA, capital A over dt. Good. So mainly just dA over dt. Good. The other side. How do we find derivative of this guy? Actually, we don't need the product rule for this guy. Why? Because this is straight up multiplication. I'm not going to deny that. That is multiplication there.
Is it because pi is a number?
Pi is a number. Pi is not a variable, right? So that's like saying 2r squared. That's like saying 4r squared. That's like saying pi is a variable. Or sorry, it's a value, right? So what would we do with that 2? We move it to the front, multiply by what's already there, right? So it's 2 pi r to the first power, right? And then what?
D pi
What did I find derivative of?
R.
times r.
dr over dt. dr over dt, because that's the only thing I found derivative of on this side was r. I didn't find derivative of pi. So essentially you would have dA over dt equals 2 pi r dr over dt. Essentially that's what it is. That's the derivative. It's good review because this is going to, it's called implicit differentiation. It was the first thing we did in this unit. It's been a while, but we have done it. It's good review. This section is good review for, that's why I leave it right before review, because that's some of the stuff we're going to have to review. Okay? Okay, so that's kind of the background. Okay? How are we going to solve these guys? Here are the steps right here. Put the steps right there. Each of them, we're going to use most of these steps. So the ones we do today, we're not going to use step 4. Yeah, step 4 we're not going to use today. We'll use it tomorrow. And I'll explain why when we actually start doing the problems. So sometimes you won't do step 4. You'll always do step 1, step 2, step 3. Sometimes you'll do step 4. You'll always do step 5 and step 6. Okay? Couple things to know. If something is increasing, remember the rate is positive. If something is decreasing, the rate is negative. Okay? It makes sense. It's common sense, right? But sometimes we forget those things. Okay? Product rule. Sometimes we will have to use the product rule. Okay? All differentiation will be implicit. So what does that mean? Tags. That just means tags. Don't forget tags. Almost all the tags will be dt over dt. Something over dt. Okay? Don't forget about units, because if they give you units, you got to return in units. So if they say inches, hours, dollars, years, return it in units. So if something is constant, what is its rate? Or so if something, how can I say this? Don't plug in numbers to the original equation for things that are not constant.
0?
0, right? It would be 0, right? Because it doesn't change. That's what that means. It's bad wording, but that's what that means. Okay? Rarely do we use that one, but we will. So these are the ones we want. So these are the steps we're going to use for every single problem we see in related rates. If just stick to these steps, and you will be fine. Okay? Related rates are always easy problems to tell, oh, this is related rates, because it talks about a rate. It talks about rates. Okay? All right, so let's do the first one. Let's do example number 3, even though it's really example number 1. Okay? Okay, so you have a rectangle. Rectangle has a length of 1 inch and a width of 6 inches. Okay? Those sides are changing though. They're not going to stay 1 and 6. They're changing. The length is increasing by 4 inches per second. The width is growing by 8 inches per second. What is the rate of change of the area? Okay, so what is the rate of change of the area? That's what they want to know. So let's go back to our steps. We didn't talk about them because I wanted to go one by one. Step 1, write what you are given. They always tell us things. I always start with a picture. What picture do they have? So let's start here. Let's start with a rectangle. It's a rectangle with 1 inch is the length. So that's the short side. So we have 1 inch, 1 inch, right? And then we have 6 inches. 6 inches. Okay, so for every horizontal side on a shape, I'm going to call it x. So I'm going to say, because x is horizontal, right? I'm going to say this is x and this is y. Every vertical side, I'm going to use a y. Do you have to? No, but it's going to make your life easier later. So just trust me on this one. Okay? Okay. So we know a couple things. We know x, that's one of the sides, right, is 6 inches. We know y, the other side is 1 inch. Those aren't rates, those are actual distances, so they don't get a time. What else do we know?
That x is increasing by, or x is each.
So 6x is growing at a rate of
8 inches per
8 inches per second, right? So we know 8 inches per second, right? What is growing at 8 inches per second?
dx over dt.
There you go, good. not x, because x is a distance. How do we write x as a rate? Dx over dt. That says x is the rate of x. And then we know dy over dt is 4, right? Increasing at 4 inches per second. Do we know anything else? Do they give us any other given information? No, that's it, right? That's it, that's all we know. Okay, that's step 1. Always list what you're given. Draw a picture if you can't. Step 2, write what you are trying to find. In other words, the question, right? So what was the question of this guy?
The rate of change in the area?
Of the area. The rate of change of the area. I don't know that guy. So I'm going to put a question mark. How do I label that guy, though?
Rate of change in the area?
How do I label this guy? So if I put this, area equals I don't know, because I don't know what it is, right? Would that work?
No.
No, because it's not, because it's a rate of change. So how do I write area as a rate of change?
dA over dt?
There you go, d capital A over dt. Good. If I had that answer, I'd be happy. That's step 2. Step 3 is why they call it related rates. Step 3 is why they call it related rates. I need an equation that relates all of these variables. I need an equation that relates the sides, length and width, and area of a rectangle. So go back into your memories. What equation, I'm talking about like years back, go years back, or formula I should say, maybe a better word is formula. Which formula would relate all of those guys? Sides of a rectangle, area of a rectangle,
Height times width.
area of a rectangle, right? Area of a rectangle. Area of a rectangle is length times width, right? Well, what is our length and what is our width?
Length is 1.
But it's not, so you're thinking in terms of right now. I'm thinking in terms of forever. What is our area of our rectangle?
1.
That's right now. That's right now. Length times width, which is what? And ours, what is that?
6 times 1.
That's right now. I'm talking about any time. I'm talking about in 1 second, 2 seconds, 3 seconds. What is our formula?
dx over dt times
No.
8 times 4.
X times y. There you go. Isn't this always going to give me area of a rectangle? X times y? Because if you say 1 times 6, that's just right now. But what about in a second? What about in 2 seconds, in 3 seconds, in 4 seconds? Right? It's whatever x is times whatever y is. That's step 3. Okay? Step 4 we don't need today. When we get to those problems, you'll know when you need step 4. We don't need it. Step 5, differentiate with respect to time. What does that mean? Differentiate with respect to time. Find the derivative with respect to time. So find the derivative of that guy. What is the derivative of A? dA over dt.
equals dx over dt times dy.
No. Product rule, there we go. We got to use product rule for x times y. So first times the derivative of y. What's the derivative of y?
dy.
dy over dt, good. Plus, reverse. The derivative of y is 1. Oh, sorry, let's see. Y times the derivative of x. What's the derivative of x?
dx.
dx over dt, because everything is with respect to time. Okay, so let me label this. Step 1 was all of this. Step 2 is down here. Step 3 is over here, and this is step 5. Okay?
Where's step 4?
We didn't do step 4 for this problem. That's why it's got a star on it. Step 6, plug in and solve. Plug in and solve, step 6. Plug in and solve. So what is dA over dt? What is the number they've given us for dA over dt? We don't know, so we'll leave that blank, or we'll just leave it dA over dt. What is the value they gave us for x? 6 inches, right? So we'll put 6. It's inches. We'll come back to units later. What is the value they gave us for dy over dt? 4 inches per second. What is the value they gave us for y? 1. What is the value they gave us for dx over dt? 8 inches per second, right? So in math, when you only have one variable, you can solve for that variable, right? That's what we're going to do. We're going to solve for dA over dt. So we got 24 plus 8 is 32. Last thing is give it units. So what units go with 32?
Inches per second.
Inches per second, because it's a rate. It's a rate, so it's inches per second. We are done. Done. Okay? So as it's increasing, how fast is the area increasing? At 32 inches per second. Okay? All right. Let's look at the next one. Let's look at the next one.
Couldn't we have just done 8 times 4?
I don't know. Let's see. Let's look at the next one. Let's see if it works. Let's see if it works on the next one. Let's see if there's a pattern with the next one. A right triangle. Draw a right triangle. Draw a triangle with one right angle. Okay, so we have a right triangle. Remember, any horizontal side I call x. So I'm going to call this x, and I'm going to call this y. Any vertical I call y. Since this guy is not vertical or horizontal, we'll call it z. So step 1, what do we know? We know it's a right triangle, and we know legs, it has legs of 33 and 44. So one of them's 33 and one of them's 44. Which one's which? Doesn't matter. It doesn't matter. You can make x 33 and you can make y 44 or vice versa. Those sides are changing though. Those sides are not going to stay the same. Okay, so we know x is 33 inches. We know y is 44 inches. What else do we know? We don't know z. I don't know what z is. But I know that the short leg, x, is increasing by 4 inches per second, and that the long leg, y, is shrinking at 10 inches per second. So how do we write that? How do I write that on my list?
dy over dt equals negative 10 inches per second?
Yeah, so that's the shrinking one, right? The longer leg is y. So the rate is it's shrinking. It's shrinking by 10 inches per second. So that's negative 10 inches per second. And then dx over dt. That one's increasing. It's increasing by 4 inches per second. Okay. Do I know anything else? Is there any other given information that I haven't put on paper
Well,
yet?
we need to find the rate of change of the hypotenuse.
Did they tell us that? No, so it's not given. That part's not given. So any given part that they have. That's it. Okay. Move on to the next part. What is it that we're trying to find? We're trying to find the rate of change of z. So am I going to write z equals? Is it a distance they're trying to find, or is it a rate they're trying to find? It's a rate. So I can't write it as z. How do I write that as a rate? dz over dt. Good. dz over dt. Good. Okay. So I have two lengths of a right triangle, and I need to find something about the length of the hypotenuse, the rate of the hypotenuse. Well, what is a, there you go, the formula, the famous formula, a squared plus b squared equals c squared, right? That tells me about this, and it tells me about the length, right? So that's what I'm going to use. But I'm not going to use a squared plus b squared equals c squared. Why not? Yes, that don't match my variables, right? I don't have x, a, b, and c. I have an x, y, and z, right? So I'm going to say x squared plus y squared equals z squared. So again, this is step 1, this is step 2, this is step 3. Step 4 we're not doing today. So what is step 5?
Write the derivative.
Derivative. We already kind of did the derivative of this guy, right? Except instead of x, y, and z, we used a, b, and c. So what would the derivative of this guy be? 2x dx over dt, good, plus 2y dy over dt equals 2z dz over dt. Okay. Last step, plug in everything. Okay, so let's set this up. 2x dx dt plus 2y dy dt equals 2z dz dt. I know 2. What is x? 33. What is dx dt? Positive 4. What is dy, or sorry, what is y? 44. What is dy dt? Negative 10, good. Last 2. What is z?
22? Oh, wait,
We don't know.
We don't know. What is dz dt?
we
We
don't
don't know.
In math, you can't solve if you have 2 variables. So I have to solve for either z or dz dt. How do I do that?
You can solve for z by using the original equation.
Yep, solve for z. I can solve for z. I don't know what it is, but I can solve for it. How do I solve for the missing part over here?
E squared 44 and 33.
Use the Pythagorean theorem, right? Yeah, use the Pythagorean theorem. 33 squared plus 44 squared equals z squared. 33 squared is 1,089. 44 squared is 1,936. Add those two up, you get 3,025. How do I solve for D? Square root both sides. The square root of 3,025 is actually 55. The reason I was able to do that so fast is because it's a special type of right triangle. It's a 3, 4, 5 right triangle. It's a 3, 4, 5 right triangle. If you divide them all by 11, it would be 3, 4, and 5. So now I know Z. Well, I knew it to begin with, I just didn't find it. I just didn't solve for it. So we actually know Z is 55 inches. So that means 55 over here. dz over dt. I have one variable, which is fine. Okay, so now multiply, add, multiply, solve for dz over dt. All right, so first thing, this guy here, when I multiply 2 times 3, 33 times 4, I'm going to get 264. When I multiply 2 times 44 times negative 10, I'm going to get negative 880. And then this guy, I'm going to get 110, but it's got a tag. Add, you're going to get negative 616. How do I solve for dz over dt?
Divide by 110.
Divide by 110. So either reduce the fraction, or if it's a calculator question, some of these are calculator questions, some of these where you can use a calculator. So if you can use a calculator, obviously use one, but if you can't, just reduce. So you would get dz over dt equals, I think if you reduce it, you would get negative 308 over 55. Which is the same thing as negative 5.6. Units. Inches, seconds, inches per second.
Inches per second.
Inches per second, because it's a rate. Okay. This is a correct answer. This is a correct answer. Just depends on which one you're. Okay. All right. Okay, so let's go to number 5. Sorry, 5. 5's got two parts to it. 5 is actually a former FRQ question on the test that I stopped using just because I used it a few years and then I changed the question and I just put it on my notes just because it's a good example of a multiple or a free response question that you could see. Okay? Okay, so here we go. We got a 25-foot ladder is leaning up against a vertical wall. The bottom of the ladder is being pulled away at a rate of 3 feet per second. How fast is the top of the ladder moving when the bottom is 15 feet away from the wall? So what I want you to do is two things. Draw a picture, label what we have. Draw a picture, label what we have. Draw a picture, label what we have. So I know the hypotenuse. What is the hypotenuse?
25 feet.
Because, how do I know it's 25 feet? You're right.
Because the ladder is leaning against the straight wall.
Because the blue is the ladder, right? Yeah, that's the ladder part. So I know Z is 25 feet. Good. That's one thing. What else do I know? I know a couple other things.
dy over dt is 3 feet.
So yeah, it's going to depend on which one is x and which one. Oh yeah, sorry, no, this was x, this is y, yeah. So say it again.
3 feet per second.
What is what?
dx over dt.
Dx over dt is 3 feet per second. So what's happening there? What's happening with x? It's being pulled away. So is 3 going to be positive or negative?
Negative.
Because you're right, it's actually positive. Why is it positive?
It's getting longer.
It's getting longer, yeah, x is getting longer. X, so this guy right here is being pulled in that direction. That's what's happening. So x is getting bigger. So if x is getting bigger, it's growing. So that means 3 is positive. Good. What else do I know?
X is 15.
X is 15. The bottom is 15. So the top of the ladder, how fast is the top of the ladder moving when the bottom is 15 feet away? So this is 15 feet, yep. 15 feet away. And that's not a rate, that's just a measurement. Do I know why? Could I figure out why? Do it because you might need it later, right? It's not given, but with a little bit of work, you can figure it out. So what is y? So x squared plus y squared equals z squared. Fifteen times 15 is 225. 25 times 25 is 625. Subtract 225 from both sides. Take the square root of both sides. Square root of 400 is 20. So y is 20 feet. Again, not given, but we could figure it out. Again, it's a 3, 4, 5 right triangle. If you divide all of the sides by 5, you get 3, 4, 5. Most common right triangle. That's it. That's all I know, right? What am I trying to find? How fast? What is changing? What's going to be changing?
y.
Y is going to be changing, right? The top of the ladder, where is the top of the ladder going to be going when x is going to the right?
Down.
It's going to be going down, right? So dy over dt, that's what I'm trying to find. Dy over dt. That's what I'm trying to find. What is the formula that wraps all of this together? Pythagorean theorem again. Luckily, we've done it before. So we're just going to do this. We're going to do a little bit of a quick. I'm going to say x squared plus y squared equals z squared. But I'm not going to find the derivative because I already did. You just did on the last one, right? So the derivative is 2x dx over dt plus 2y dy over dt equals 2z dz over dt. Plug in, solve, you're done. Okay. So 2 times x is 15, times dz dt, or sorry, dx dt, which is 3, 2 times y is 20. dy dt, I don't know, right? So that's one's going to stay dy over dt. I don't know that guy. 2 times z, I know z is 25. Good thing I figured out all of that. What is dz dt? I don't have dz dt on my list. But what is it?
0 or 1, whatever.
It's actually 0. Why is it 0?
Because it's a constant rate that's not changing.
What is a constant rate that's not changing? You're right.
The ladder, the length of the ladder.
Yeah, the ladder's not getting longer, right? The ladder's not growing or shrinking. It's staying the same. So its rate of change is 0. Okay. So 2 times 15 times 3 is 90. Plus 2 times 20 is 40 dy over dt equals 0. Subtract 90 from both sides. Divide by 40. And you get negative 9/4, which is negative 4.25. So I have 2 questions, then we're done. First question, what is the units?
Feet per second.
Feet per second. Second question is more of a common sense. It's a negative number. We haven't had a negative answer. Is that okay?
Yeah.
Why is it okay? Didn't we say that y was shrinking? So it should be a negative number, right? There you go. Always do that. Always do the common sense question. Does it make sense? I did all these calculations. Does it make sense? Should my answer be negative? Yeah, we kind of said that, right? Y is getting smaller. Okay? All right.